Good morning, Knights. Welcome back to Chemistry Online. Today we're going to be talking about periodic trends. So, periodic trends. What are trends? So, a trend is basically a pattern. Pretty sure my spelling is right. So, a trend is basically a pattern. And when we're talking about periodic trends, we're talking about patterns that we see on the periodic table. So, at the top of your page, you're going to write down periodic trends. All right, so before we get into periodic trends, I want to talk to you guys about ions. So ions are really important. Let me shrink this guy real quick. So ions are really important because they matter a lot with the types of questions you're going to see. So I could teach you an entire topic, but they could ask you a question about an ion. And if you don't know about ions, you're going to get the question wrong. So what is an ion? An ion is an ion is a charged particle. So an ion is a charged particle. So it's a particle that either gained or lost an electron. So here it says it's in an ion, the number of protons and the number of electrons are not equal. That's another way to put it. So let's say we have something off the periodic table. So let's say we have hydrogen. So hydrogen has one electron. If hydrogen had less than one electron, if it gave one away, then hydrogen is going to have a minus charge. Sorry, it's going to have a positive charge. So when you lose an electron, you have a positive charge. Now let's say hydrogen gained an electron. If that's the case, then hydrogen would have a negative charge. So an ion is either a positively charged hydrogen or a negatively charged hydrogen. But it either gained or it lost an electron. That's what an ion is. And the way to identify ions is they're always going to have either a positive or a negative sign on them. And then sometimes it'll have a number. So let's say we have something like oxygen. So oxygen, when it gives away when it gains 2 electrons, it's going to have a 2 minus charge, which means it gained 2 electrons. Something like lithium. Lithium has 1 electron. When it gives it away, lithium has a possibility of being an Li+. So basically, when it gives away its electron, when it does what it wants to do, it becomes the ion. All right, so in lithium has 3 protons. After it gives away its electron, it's going to have 2 electrons. So 3 protons, 2 electrons. That's one way of identifying the whether it's an ion or not. But so 3 protons, 2 electrons. That's going to be an ion. All right, so there's 2 types of ions. There are cations and there's anions. And there's a very easy way of remembering these. So cation, C-A-T-I-O-N. The way I remember it is the T looks like a plus. So these are going to be positively charged ions. So the T looks like a plus. That's going to be a positively charged ion. So here with lithium, it's got the plus sign. This is a cation. Next one we have is anion. So anion, the way I remember that one is A negative T-I-V-E ion. So A negative ion. And that's how you remember these. So a negative ion, an example of that is going to be anything on the right side of the periodic table. So fluorine, once it gains an electron, it becomes F-. This is an anion. So it's an anion. I'm just going to draw. Another example is going to be something like oxygen. So oxygen, after it lost 2 electrons, that's going to be another example of an anion. All right, so let's go ahead and move on. All right, so here's what you need to write. So if you didn't write anything from the previous page, you should have written stuff. But if you didn't write anything, this is it boiled down. So an ion is an atom that lost or gained 1 or more electrons. So that's what an ion is. It's an element that lost or gained 1 or more electrons. All right, so cation, that's the positively charged ion. Anion, that's the negatively charged ion. So the charge on the ion is known as the oxidation number. That's a word you need to know. So this right here, that's the oxidation number. This right here, that's the oxidation number. And we're going to talk more about oxidation numbers later because those are what determine what something can bond to. All right, so an atom likes to be equal so that it can remain neutral. So every element on the periodic table is already neutral. It's so that basically means that if it has 6 protons, it wants to have 6 electrons so that it can be neutral. Therefore, an ionic bond is formed. Oh, this is ionic bonding. We're not going to talk about ionic bonding today, but this is going to be its own day coming soon. Yeah, let's just go ahead and move on. All right, so today we're going to be talking about periodic trends. So periodic trends, these, we'll talk about them in a second. So today we're going to be talking about periodic trends. So once we set up the periodic table, we basically found out that there were patterns. So as you move left on the periodic table, elements get smaller. As you go down rows on the periodic table, elements get bigger. And their attraction increases as you go up and to the right. So these trends are what we're going to be talking about today. All right, so there are 2 main factors that affect periodic trends. This is there are actually 4, but we're only going to talk about 2, the 2 most important ones. So the first one is going to be nuclear pull. So every element has nuclear energy in it. That energy is what's holding the atom together. If that energy wasn't there, the atom would just fall apart. So that's one of the most important things when it comes to periodic trends. So it says nuclear pull. The way I like to think about it is electronegative pull. So electromagnetic. So here we have a positive charge and here we have a negative charge. And the positive charge pulls the negative charge to it. So the nucleus, which is positively charged because it has protons and neutrons. Neutrons have no charge. So the nucleus, which is positively charged, it attracts the electrons in the outer shell. And it's basically what holds everything together, that electronegative charge. So that's what this nuclear pull is. The protons, they pull on the outer electrons, and the more protons, the more pull that there is. So when an element has more protons, it's going to have a larger nuclear pull because more protons. The next most important one is going to be electron repulsion. We've talked about electron repulsion before, and that's basically when when electrons push each other farther away from each other. So here we have what looks like almost a perfect sphere, and the reason for it is because these electrons are pushing each other away, and as they push each other away, they form this sphere that's as large as it could possibly be, while still being attracted to the positively charged core. All right, let's go ahead and move on. All right, so the first trend we're going to talk about today is called atomic radii. Radii basically means radius. So atomic radii. Oh, everyone should write down atomic radii. An atomic radii, that's the radius or the size of an element. So when I talk about atomic radii, we're talking about the size. And it's important to know how we measure the size. We measure it from one nucleus to another. So we can't, it's really difficult to measure from the beginning of the electron cloud to the end of the electron cloud. What's a lot easier to do is just to look at the center of 2 separate atoms, because we could see the dense nucleus, and then we just measure the distance between them. Then we divide it by 2, and that gives us the radius. So how do we measure the atomic radii? You need to know this. This you will be asked on the test. So the measure of from nucleus to nucleus divided by 2. And it's good to know like what I just explained to you, because it's not going to be worded this way when you see it on the test. It's going to ask something like, how's the atomic radii determined? And the answer is going to be by measuring the distance between 2 nuclei. Or sorry, well, yeah, that was correct. So the larger the atomic radius, the larger the atom. All right, so reactivity of metals, don't worry about that. So periodic trend, metals increase in activity, don't worry about that. All right, so here I'm going to explain it to you. You don't need to write this down. You'll write down what's on the next page. So the general periodic trend when we're talking about atomic radii is atomic radius, it's going to increase as you travel left on the periodic table. And the reason for that is as you go to the right across the periodic table, electrons are added to the same energy level. So when we're talking about energy level, we're talking about which row it's in on the periodic table. So the lower rows have higher energy levels. The higher rows have the least energy levels. So here's the periodic table. This is going to be energy level 1. So an energy level 1, basically, all it has in it is going to be the s orbital, and that's just going to be hydrogen and helium. They're the only ones in that first energy level. The second energy level is going to be the 2s and then the 2p. So this is a much larger energy level. Then the third energy level, that's going to be the one that includes the d block. So that's the third energy level. And then fourth energy level also includes the d block. And then the sixth energy level, that's the first one that includes the 2 blocks at the bottom. So that's what we're talking about when we say energy level. So atomic radius, it increases as you move to the as you go down and to the left on the periodic table. So that means here we have the smallest elements. And I want you to draw this. This is very important to draw on your periodic on your notes. So here we have the smallest element, and you're probably going to be asked that on the test. What's the smallest element? You're going to need to answer that. The smallest element actually is going to be well, yeah, we'll say it's helium. I'm not gonna try to confuse y'all. But when we're talking about the lightest element, the smallest one, most abundant, that's gonna be hydrogen, because helium is basically 2 hydrogens plus some neutrons. But so this would be the tiniest. But here, this is where we have the trend. Smallest element goes here. Largest element is gonna be right here. It's called francium. If you look at your periodic table, it sits right there. That's the largest element on the periodic table. So everyone should draw this in your notes. You're going to have questions that we're going to answer based on that. All right, so this is just another way to put it. If you didn't want to draw the last one, here's another one. So atomic size increases as you go down on the periodic table, and it decreases as you move right on the periodic table. So this could have been flipped. We could have put an arrow this way, and we could have put atomic size increases. But, you know, this could be drawn in a million different ways. So, now you know what, you need to know why. So the reason why is because every time you go down one row on the periodic table, you're basically adding an extra electron cloud. So here we have hydrogen. Hydrogen has 1 electron cloud. But then lithium, which is right below it, is going to have the same electron cloud as hydrogen, but then it's going to have another one around that too. So it's going to have the S2 and the P, the 2P. And then after that, we have potassium down here. Potassium is going to have a third one. So a third electron cloud. So that one's very easy to understand. So every time you go down a period on the periodic table, you're increasing 1 electron shell. So when you get an extra electron shell, the element becomes larger. So why do elements get smaller as they move right? That one, a lot of people, they miss this question on the test. But the reason they get smaller as you move to the right is because every time you add more protons and more electrons, you're increasing the electromagnetic pull. So NOF, that's nitrogen, oxygen, fluorine. So fluorine has 7 plus 2, so 9 electrons, 9 protons. Oxygen has 8 electrons, 8 protons, and then nitrogen has 7 electrons, 7 protons. And as you increase the number of electrons and protons, you're increasing the electromagnetic charge. And when you increase the electromagnetic charge, the elements get smaller because the positive is pulling more strongly on the negative, which causes the element to become smaller. And I have a picture to show you this in a second. But here's nitrogen, here's oxygen, and then here's fluorine. As you increase the number of protons and electrons, it becomes a little bit smaller. So this is the best picture that you'll ever find of the periodic trends. It basically shows you what elements do or how they shrink. And here you can see cesium, but underneath cesium we have francium, the one I was telling you all about earlier. So francium is larger than cesium. But basically, as you move to the left, elements get larger. As you go down on the periodic table, elements get larger as well. So when we're talking about periodic trends, you should be able to answer some of these questions. All right, so let's take a look at this one. It says circle the atom with the largest atomic radii. Let me grab a periodic table because I've been over here trying to work without one, and it's really hard to do, so you guys should pull up y'all's periodic tables. All right, I'll bring it over to this side. All right, so it says circle the atom with the largest atomic radius. So which one has the largest atomic radius? Iodine. All right, I can't do that. So y'all should be looking at your periodic tables as we work through these. So circle the one with the largest atomic radii. So we have iodine, and then we have fluorine, and then we have chlorine. So if you have your periodic table in front of you, then you'll know that these are all in the same column. These are all in group 17. And you have fluorine, below it you have chlorine, below that you have bromine, and then below that you have iodine. And it wants to know which one is the largest. So this one's a very easy question because we know that the trend, so let me draw a little periodic table here. It's a really bad periodic table, but we know our trend looks like this, which means fluorine is going to be our smallest. And as you go down rows on the periodic table, you're adding additional electron clouds. So the largest element in this group is going to be iodine. All right, so the next one is going to be oxygen, boron, and nitrogen. So those are in the same row, different columns. So it's going to be boron, carbon, nitrogen, oxygen. So which one is the largest in this group? It's going to be boron. The reason it's boron is because it's got the fewest number of electrons and protons, which means it has the lightest electromagnetic pull, and because of that, it's just a smaller element. Next one we have is sulfur, Sb, which is antimony, and strontium, and these guys are not even close to each other. So the way these look is you have sulfur over here, you have Sn over here, and then all the way on this side of the periodic table you have Sr. So we know this one is the smallest because our trend, it looks like this. That's going to be our smallest. And these two are they on the same row? Yes, they are. So this one's real easy now. So strontium is going to be the correct answer here because this one is farther to the left. All right, number 2 says put the following in order. You're gonna see a lot of questions like this as we move forward with atomic radius. So put the following in order. So we have sodium, phosphorus, and rubidium. All right, so if we were looking at the periodic table, sodium would be up here, rubidium would be here. They're in the same column, just 2 away from each other. And the last one we have is phosphorus, which is over here. And so this one's not as easy because this one has different. They're in the same column, and then it's got ones that are in the same row. So if we were to compare phosphorus to sodium, phosphorus would be larger than sodium. So here, sodium is going to be the smallest. Phosphorus is going to be second smallest, and then rubidium. It's got the 2 additional electron shells, which makes it the largest. So that's going to be 3. So increasing atomic radii, we're going to put Na, P, and then Rb. So they were actually in correct order when they were given to you. Which element has the largest atomic radii? So they're asking here basically based on the entire periodic table. And the answer to this one is going to be francium. Any questions on atomic radii? All right, let's move on. All right, so last thing we're going to talk about as we discuss atomic radii is going to be cations and anions. So that's the reason we talked about ions before. So ions are elements that lost electrons. When they lose electrons, do they get smaller or do they get larger? There's a basic rule. If you know this one rule, then you'll be able to answer all questions that are like this. So cations are smaller than their parent atoms, which means if we had lithium and then we had lithium plus is going to be smaller than lithium. So when you lose an electron, you become smaller. That's basically it. And then if you know that, so I'm gonna label this smaller. And then if we were talking about anions, so let's do fluorine. So fluorine, when it gains an electron, it actually becomes larger. So cations are smaller than their parent atoms. Anions are larger than their parent atoms. So that's basically all you need to know about these. And just to let y'all know the reasoning behind it. So when you lose an electron, there's a stronger electromagnetic pull towards the fewer electrons that are there. And because of that, the element becomes smaller. And when you increase the number of electrons, it decreases the amount of electromagnetic pull between the protons and the electrons. So that causes the element to get just a little bit larger. It's not noticeably larger, but it is a little bit larger, and you need to know that it is a little bit larger. All right, and then ionization energy, we're going to save this for next class. So that's all for today. Have a good rest of your day.